If you write count star inside a where clause in an AI or machine learning engineering interview, the interview is effectively over.
Oh, yeah. It is a hard stop. It proves to the interviewer that you fundamentally do not understand how the SQL engine physically processes data.
Right. It's a conceptual failure regarding system architecture,
Yeah.
not just, a simple syntax typo.
Exactly. It shows a flaw in how you think about the engine itself.
So to fix that mental model permanently, we need to ground this in a real continuity dataset. We're looking at a standard users table today.
Very standard. Something you'd see in almost any technical assessment.
Yeah, so picture the columns. We have EID, name, age, country, and sign update. So we're dealing with records like Amit, who is 23 from India,
Right.
or Sarah, 30 from the USA, Raj, 28 from India, and John, 35 from the UK.
Like I said, a very realistic user table that candidates will encounter in that initial data exploration phase.
For sure. So here's the anchor problem we are tackling today, based on that data set. Find countries having more than 2 users.
Okay, good one.
If you're listening right now, map this out in your head before we give the answer. Pause and think about how you will solve this interview coding question. Are we filtering rows or are we filtering groups?
And ask yourself, when is count star actually computed by the system?
Right. Can the where clause even access that count star? Welcome to the AI and ML YouTube channel by 60 Seconds Academy. Here we focus on practical and application-based understanding and concept clarification so that you can be industry-ready and apply your knowledge to real industry projects.
And our mission for this deep dive is to ensure you completely master row versus group filtering.
Yep.
By the end of this conversation, you will understand the physical SQL execution pipeline at a hardware level. You will permanently avoid that fatal count and where mistake.
Which is huge.
Huge. And most importantly, you will learn how to apply performance-aware SQL thinking to time-bound interview questions. Because, in AI and ML, getting the correct output array just isn't enough.
No, you need the most computationally efficient query to feed your pipelines.
Exactly. So to understand why that interview killer mistake happens, we first have to look at the physical order in which SQL processes data.
Right, because we can't just write code left to right. We have to, actually think like the database engine.
Yeah, that's the whole discrepancy. It comes from how we read English versus how a parser operates. I mean, we read a query starting with the select statement.
Which makes sense to us.
Right, but the engine does not do that. It follows a strict physical pipeline. The absolute execution order is first from,
Okay.
second where, third group by why, fourth having, and only then fifth does it reach select.
Okay, let's unpack this. Let's put a physical analogy to this so it really sticks.
I love analogies. Let's hear it.
Imagine the database is a massive, highly exclusive nightclub.
Okay.
The firm clause is the building itself, right? The venue where the data lives.
Makes sense.
The where clause is the bouncer at the front door. That bouncer looks at individual IDs and decides who gets inside the club, effectively filtering individual rows one by one.
Right, checking rows at the door.
Next, the group P by Y clause is the club staff inside the venue, organizing the admitted guests into specific VIP sections based on a shared attribute.
Like what country they're from.
Exactly. They're forming the groups. Then, the having clause is the general manager walking around after all the groups are formed.
Ah, after they're formed.
Yep, looking at the VIP sections and kicking out entire sections if they don't meet a minimum spend or head count.
And finally, select is the photographer taking a picture of the sections that survived the night.
Exactly.
That perfectly illustrates the golden lock-in concept of SQL data processing, which is you cannot filter a group before creating it.
Right.
I mean, how can the manager evaluate a VIP section if the staff hasn't even grouped the guests together yet?
They can't. They physically can't do
They
it.
simply can't. Understanding this physical sequence shifts your mindset away from just blindly memorizing syntax rules.
And moves you toward actual system comprehension. You begin to see the memory allocation happening under the hood.
Yes. So let's apply that directly to how candidates accidentally try to fire the bouncer and ruin their technical screen.
Oh man, yeah. Here is the fatal query we see all the time. Select country, count star from users where count star is greater than 2 group by country.
And the engine reads that and throws an immediate error. Let's dissect the failure based on that nightclub pipeline.
The candidate placed count star greater than 2 inside the where clause.
Right. But where operates at step 2? Group by Y doesn't happen until step 3.
So the bouncer is standing at the front door trying to count how many people are in a VIP section that has not been built yet.
Precisely. Because where runs before group by. The count star aggregation has not been computed yet.
It doesn't even exist.
Exactly. The system's memory has zero reference for what the count is at that specific microscopic stage of execution.
Wow.
Writing that in an interview signals that you don't know the physical order of operations of your primary data extraction tool.
So the correct approach for our anchor problem, finding countries having more than 2 users, required shifting that condition to the correct phase.
Yep.
The correct query is select country, count star from users group by country, having count star greater than 2.
That's it.
And when run against our dataset featuring Amit, Sarah, Raj, and John, the output is a single row, India, with a count of 4.
We formalize this as the post-aggregation filtering pattern. It's a foundational concept.
Right.
The mental trigger to rely on during a high-pressure interview is phrasing. If the prompt asks for groups having or countries with more than or users with an average, that indicates aggregate level constraints.
Because you can't have an average of a single row.
Exactly. And that always dictates the use of the having clause.
Okay, getting the syntax to compile is the baseline. But we need to push further into system mechanics.
Let's do it.
What do we do when we have conditions that could theoretically compile in either the where clause or the having clause?
Now that introduces the where versus having performance framework. We use the Gemini upgraded performance golden rule. If you can filter in where, do it there.
Nice and catchy.
Right. Let's look at a specific example. Suppose the interviewer says, we only want to look at users from India and we want to group them to see the total.
Okay.
Do you use where country equals India before grouping, or do you group every single user in the data set into countries first, and then use having country equals India to discard the rest?
Oh, wow. It's like trying to reduce your luggage weight by packing everything you own into suitcases first, dragging all of it to the airport, and only then deciding what to throw away at the check-in counter.
That is exactly it.
It's a massive waste of energy.
And that is the exact computation cost.
Right.
Where reduces the number of rows early in the pipeline.
Right.
If your dataset contains 1 billion users and only 10 million are from India, filtering at the where stage means the subsequent group by-off operation only has to allocate memory and perform sorting operations for 10 million records.
Instead of 1 billion.
Exactly. Having works after grouping. If you delay the filter until the having stage, the database engine must allocate memory to group all 1 billion records.
Oh my gosh.
It has to calculate the aggregates for every single country and then discard 99% of that work.
So what does this all mean for system memory? Is having essentially a more expensive operation because it has to process the entire crowd before making a decision?
Yes, absolutely. Where saves computation. Having costs computation.
Okay, let's issue a second pause for the listener to test this logic. If I want only India users, and I only want that group returned if their user count is greater than 2, where does the filtering happen?
You have to split the logic across the pipeline.
Right. The where clause handles the geographic filter. Where country equals India filters the raw rows early.
Yep.
Then the group by Y clause does the aggregation. Finally, the having clause handles the mathematical threshold. Having count star greater than 2. That filters the aggregate group after the math is done.
Perfectly stated.
Okay, saving computation is great in theory, but when I'm pulling a massive data set to train a machine learning model, say a recommendation engine, how much does this physical execution order actually matter for the ML pipeline?
Oh, it fundamentally dictates the quality and speed of your model training.
Really?
Yeah. When pulling data for a recommendation system, you deal with scale and noise. In this context, the where clause acts as a metadata filter.
A metadata filter, got it.
Early in the query, you write, where is bot equals 0. You strip out bot traffic immediately at the door because you cannot afford to have synthetic data poisoning the tensor inputs of your model.
Right, because bots don't exhibit human purchasing intent. Training embeddings on bot clicks would warp the entire recommendation space.
Exactly. The having clause then acts as a behavior filter.
The behavior filter, okay.
You group the remaining verified human users by their ID and apply having count logins less than 1,000.
Ah, I see.
You do this because if a user logs in 1,000 times in a single day, that is an anomaly. It might be a compromised account or a scraping script.
You cannot identify that anomaly at the row level. You only spot the behavioral outlier after you aggregate their activity.
Precisely.
So where filters metadata at the row level and having filters behavior at the aggregate level, that conceptual bridge between data engineering and model integrity is vital.
It really is. It separates the coders from the engineers.
Let's pivot to some of the advanced edge cases interviewers use to test the depth of this knowledge. Starting with the alias gotcha.
Oh, this is a sneaky one.
If a candidate writes select country, count star as user count from users group by Y country, and then follows it with having user count greater than 2, what happens?
Well, certain modern SQL dialects, like specific versions of MySQL or Postgres, will actually execute that query out of sheer convenience.
But relying on that in a strict interview setting is dangerous
Very dangerous.
because it violates the standard execution pipeline we just established.
Strictly speaking, aliases defined in the select clause shouldn't be accessible to the having clause.
Because having executes at step 4.
Right. And select doesn't execute until step 5.
So the alias doesn't exist yet in standard SQL parsing.
Exactly. By explicitly writing having count star greater than 2, instead of relying on the alias, you demonstrate to the interviewer that you understand the pure standard SQL parsing order. It proves architectural awareness.
Let me push back at another edge case. Here's where it gets really interesting. I've seen documentation suggesting you can use having without a group by clause.
Yes, you can.
For example, select count star from users having count star greater than 5.
Yep, perfectly valid.
Wait, really? I've almost never seen having used without group by Y? Doesn't that
Yeah.
break the rules? Practically speaking, why would I ever use having without group by?
It sounds counterintuitive, I know.
It sounds like a neat party trick to pass a senior screen, but does it actually have a use case in production code? How can the manager kick out a VIP section if the staff didn't form any?
It seems contradictory, but it has a specific production utility. When there is no group by Y clause, the SQL engine treats the entire table as one implicit group.
The entire venue is one single VIP section.
Exactly. It calculates the total count of the table. If that total exceeds 5, it returns the value. If it does not, it returns an empty set.
So it's basically a binary threshold trigger.
Yes. In production, you might have an automated ML monitoring script that checks a daily error log table. You only want the script to pull data and trigger an alert if the total errors cross a critical mass.
Right.
So you write, select count star from modelers having count star greater than 1,000.
And if the errors are below 1,000, the query returns nothing.
Exactly, saving the downstream pipeline from processing a nominal state. It is a highly specific mechanism, but understanding that the table itself becomes the implicit group is advanced system knowledge.
That is fascinating. Okay, let's talk about execution under pressure. Knowing this theory is one thing, but verbalizing it while a senior engineer is watching you code live is another.
It's terrifying for a lot of people.
We need to discuss how to train that mental muscle.
The required technique is the think aloud script. When you encounter aggregation problems in an interview, you must explicitly state your processing logic. As you structure the query, you verbalize where filters rows before grouping, having filters groups after aggregation. Count cannot be used in where because aggregation happens later.
Stating that logic proves you aren't just guessing syntax until it compiles.
It shows confidence and mastery.
To reinforce this, we have 4 levels of practice for you to test yourself on later. Level 1, find countries with more than 5 users.
We've heavily covered the mechanics of that. That's the baseline.
Yeah. Let's actively debate level 2. Find countries, excluding the USA, with an average user age greater than 25.
The execution path for level 2 requires balancing both clauses.
Right.
The condition excluding the USA is a row-level metadata filter. You must place where country not equal to USA before the group BY.
Because if you use having country not equal to USA, you are forcing the database to calculate the average age of all users in the USA, only to discard that calculation immediately after.
Exactly. The having clause should solely handle the aggregate logic, which is having average age greater than 25.
Beautiful. Let's walk through level 3. Find sign-up years with more than 100 sign-ups.
This introduces a transformation step. Your raw data has a sign-up date timestamp. You cannot group by the raw timestamp because every second is unique.
You'd end up with millions of groups of size 1.
Right. You must first extract the year. The engine parses the extraction, groups by that extracted year, and then applies the behavior filter having count star greater than 100.
That makes total sense. And level 4, which introduces complex row-level evaluation within the aggregate.
Hmm.
Find countries where the youngest user is greater than or equal to 18.
We will leave that one for you to solve on your own.
Yep, applying the strict pipeline rules we've discussed today.
If you connect these SQL concepts to the overarching philosophy of an AI engineering interview, you realize the core mindset is identical to data structures and algorithms.
Really? How so?
Well, SQL is fundamentally about reducing data volume into insights efficiently. DSA is about reducing computational operations into efficiency.
Ah, I see.
Filter early, compute only what is strictly necessary, and manipulate the physical reality of the engine's memory.
That is a powerful way to look at it. Let's lock in the final pattern card for this deep dive. The core architectural rule, where is for rows, having is for
As
groups.
simple as that.
The strict execution pipeline is from, then where, then group by, then having, then select.
Don't forget it.
The performance imperative is always to filter as early as possible with where to save memory allocation during grouping. And the ultimate interview killer to avoid is placing an aggregation function inside a row-level filter.
Well said. But before we conclude, consider this advanced architectural question regarding the pipeline we just mapped out.
Oh, leaving them with something to chew on. I like it.
We've established the strict physical pipeline of SQL. We established that where is the bouncer and group by Y forms the VIP sections. But how does this mental model warp when you introduce window functions or subqueries?
Oh, wow.
Are subqueries entirely separate nightclubs operating recursively inside the main venue? Does the main bouncer have jurisdiction over the subqueries bouncer?
It's insane to think about.
I challenge you to explore how layered operations interact with the base execution sequence as you advance your preparation.
That structural interaction is exactly what separates mid-level candidates from senior architects. Take these system mechanics, visualize the memory allocation pipeline, and practice the think aloud script on those 4 levels.
It will make a huge difference.
Ensure you are fully industry ready for those upcoming AI and ML engineering interviews. And the next time you write an extraction query, visualize the engine's physical order. Save your computation and save your interview. We will catch you on the next deep dive.